Hey, welcome back. This is section 5.4 in trig. We're going to have a whole mess load more of sort of identities. These guys I'm not going to have you memorize or anything like that. If I do want you to use them, I'll give you the formula and put them on the test. Not to say that they're not important. It's just in my life they haven't been all that important. That's not to say that you may not end up in a particular field where these are important, but as far as calculus will go, you're probably not going to see these very often. You may see them once in a while, but not really. So I'm not going to require you to memorize them. You can pause the video and kind of write them all down if you want right now, or you can, okay. Okay, so you can pause the video. If not, let's just dive in to the proof. I want to at least proof one of them, and we're going to try the proof number 3. Okay. Okay. So the proof's a little bit weird. Excuse me. We're going to kind of use the right-hand side. So starting on the right. Oh, sorry. Yeah, the right. The more complicated side. We have 1/2 sine of alpha plus beta plus sine of alpha minus beta. Right? We can use the identities, the sin identity that we have memorized from previous sections, and rewrite each of these terms. Right? Okay. So this will be 1/2 times. Well, this is the same sign. Sorry, not sin. Is I'm thinking of couscous. So anyway, same sign, right? So this will be sine of alpha cosine of beta plus sine of beta cosine alpha, and then plus. And again, I'm going to use that type of identity on this guy. So you end up with sine alpha cosine beta with a minus this time. Sine beta cosine alpha. Okay. Inside these brackets, you'll see some like terms. So you have 1, 2 sine alpha cosine betas. So I have 1/2 times 2 sine alpha cosine beta. And then sine beta cosine alpha minus sine beta cosine alpha is 0. Okay, so 1/2 times that will just give me sine alpha cosine beta, which is the left-hand side of the identity, which is what we want to show. Okay. Okay. So there's that. Let's see some of the kind of exercises where you're called upon to apply the formula to break a given product into a sum. So, for instance, number 2 in the book would have a sine of 8x, sine 4x, and we'll be using. Hopefully, maybe you copied it down already. We'll have to use the first formula, okay? Because you can see it's sine, sine, just like what we have here, sine, sine, okay? Okay, so I'll go 1/2, and then sine, it's cosine of alpha minus beta, right? So it's 1/2 cosine of 8x minus 4x, then minus cosine of 8x plus 4x. Okay. And then you can simplify the insides of those cosine functions, so you'll have cosine of 4x minus cosine of 12x. And then you're kind of stuck. The only real thing you could do is maybe distribute the 1/2. So you get 1/2 cosine 4x minus 1/2 cosine of 12x. And then that would be it. So what you've done is you've taken a product, so two things multiplied by each other, it's called a product, and then you turn it into, in this case, a difference. Okay. Okay. Let's look at number 8. and we're given cosine of 5x over 2 sine of x over 2. Okay. So I go back to my chart and look for cosine sine. So cosine sine, no. Cosine sine, no. Cosine sine 4, the fourth formula. Okay. So in that case, I have 1/2 times the sine of alpha plus beta. So I'll have 5x over 2 plus x over 2. And then minus sine of alpha minus beta. So 5x over 2 minus x over 2. Okay. And just like before, you go ahead and simplify the insides of the sine functions. The first one will be, what is this equal? This is 6x over 2. And of course, that's just 3x. So sine 3x. And then minus sine of this thing, which is 4x over 2, which will just be 2x. Okay. So sine 3x minus sine of 2x. And then the only thing, again, you could do is distribute. You can't combine those two things together. Okay, they would need to have the same insides. Like if you had sine of 3x minus sine of 3x, yeah, you could combine those. It would be 0. But because they have different things inside, or angles, basically, the thing that goes into the sine function you think of as an angle, because they're different, you can't combine them. Okay, so you just end up with 1/2 sine of 3x minus 1/2 sine of 2x. And of course, the directions are they go from a product to a sum anyway, so, or in this case, a difference. So it's all good. Okay, so those are the product to sums. Now we want to look at the sum of the products. So section 2. I probably should have written these out beforehand. Just for the sake of sanity, let me pause the video and I'm going to write them all out, and then you can pause the video and copy them down if you want to, but they're on the book. Okay, so prepare for some magic. Okay, so presto, there's the formula. Hopefully that worked. There's 4 of them. This junk is all inside of sine. This stuff's all inside of cosine, just like everything else. You could pause the video and copy them down if you want. But there it is. Okay, and then the questions are essentially just go ahead and apply the formulas. Let's do a proof, right? So we always want to do proofs. Okay. So let's try to do number 4 if we can. So proof of 4. And this time, again, I'm going to start on the right-hand side. So starting on the right. Let me move my recorder. Starting on the right, I have negative 2 sine of alpha plus beta over 2 times sine of alpha minus beta over 2. Okay. Well, I have these other formulas, the product to sum formulas, so I can apply these guys, right? So which version am I using? I'm using sine sine. Okay, so up here, sine sine is the first formula. Got that in my notes. I'm kind of looking as a reference. So I'm going to have negative 2 times 1/2 times cosine of alpha plus beta over 2 minus alpha minus beta over 2. It looks like I'm running out of room really quick here. Minus cosine of alpha plus beta over 2. Plus alpha minus beta over 2. Okay. So, one thing we could do is just multiply this negative 2 and the 1/2. So you got negative 1 times, and here, when you combine those two over the common denominator, what do you have? You have alpha plus beta minus, and you need a parentheses here, alpha minus beta all over 2. So that's going to be alpha plus beta minus alpha plus beta all over 2. And then that'll equal alpha minus alpha is just 0. You'll get 2 betas over 2, which will just end up being beta, believe it or not. So on the inside there we have first cosine of beta, and then minus this thing, right? So if we combine the numerators over the common denominator, we'll have alpha plus beta plus alpha minus beta over 2. And this time the betas cancel out. So you'll just be left with 2 alphas over 2, which is alpha. Okay, so minus cosine of alpha. And then you could distribute this -1 through the terms. And you get negative cosine beta plus cosine alpha. And I believe that's what we wanted to show, kind of, right? It's just the reverse form of what we have up here. So we can, get completely to the left-hand side by using the commutative law. Remember 3 plus 4 is the same as 4 plus 3. So negative cosine beta plus cosine alpha is the same as cosine alpha minus cosine beta, okay? Which is then the left-hand side of the identity. And that's what we wanted to show. All right. Okay, let's look at some problems from the book. So this time you're given a sum or a difference, and you want to convert that into a product using the appropriate formula. So this one is cosine of 9x minus cosine of 7x. Okay, so going up to my formulas, I have cosine minus cosine. So that's formula 4. So I'll just plug that in. It's plug and chug, right? So -2 sine of alpha plus beta, so that's going to be, in this case, 9x plus 7x all over 2, and then times sine of alpha minus beta, so 9x minus 7x all over 2. And then that will turn into -2 times sine of 16x over 2, right? So this is 16x over 2, which will end up being 8x, times the sine of, what is this guy? So that would be 2x over 2, which is just x. So -2 sine of 8x, sine of x. Okay. Let's use the identities to verify another identity. So verify the identity. And this is problem, I think it says 26 in the book. We have cosine of 4x minus cosine of 2x all over sine of 2x minus sine of 4x. Okay. And this thing equals tan of 3x, supposedly. We want to show that's true. So I'm going to start on the complicated side, the left. So starting on the left, we have cosine of 4x minus cosine of 2x all over sine of 2x minus sine of 4x. Right? So we're going to use the sum to product formulas. First, for the cosine minus cosine from above, that's formula number 4. Okay, so that will be -2 sine of alpha plus beta, so 4x plus 2x all over 2, and then times sine of alpha minus beta over 2, so 4x minus 2x over 2. Okay. And the denominator, I have sine minus sine, so that's going to be formula 2, and that'll give us 2 sine of alpha minus beta over 2, and then times cosine of alpha plus beta over 2. Okay. Let's simplify that material. So I'll have sine of 4x plus 2x is 6x over 2, which will be 3x, so -2 sine of 3x. 4x minus 2x over 2 is 2x over 2, so that would just be x. So then times sine of x, divided by this guy, So 4x minus 2x over 2 is 2x over 2, which is just sine of x. And then 4x plus 2x over 2, again, that's just 6x over 2, which is 3x. So cosine of 3x. Okay. So we have a lot of nice cancellation going on. It looks like we're off by a negative, right? So if you're looking at kind of our goal on the right-hand side, it should be tan of 3x. What did we do wrong here? So it's very, very subtle, but I can kind of see it. I made a mistake when I went and did alpha minus beta, right? I just presumed that it was 4x but minus 2x, but it's not. You see how I wrote 4x? So that's incorrect. We need to correct that. Okay. So what is it? Let me correct all this. And this will be different. Sorry about that. So what do we have then instead? We have 2x minus 4x, and this will be 2x plus 4x. So the 2x plus 4x over 2, that's just 6x over 2. That won't change. That will be 3x. So that was right. That part was right. The part that was wrong is this other part. This is 2x minus 4x is negative 2x over 2, which is negative x. Okay, so 2 sine of negative x, then times cosine of 3x. Right? And sometimes I don't put parentheses in there. You can, if it's clear what you mean, you don't need the parentheses, but you know, sometimes I include them, sometimes I don't. I apologize if that's confusing, but yeah, so there's that. Anyways, what do we have then? Negative 2 sine of 3x sine of x all over. Sine is an odd function, so sine of negative x is actually equal to negative sine of x, and then we're going to get that nice cancellation of the negatives. So negative 2 sine x cosine of 3x, right? So the negative 2's then cancel out. Sine x with sine x, that'll cancel out, and you're just left with sine of 3x over cosine of 3x. And of course, sine over cosine is tan, so we end up with tan of 3x, which is the right-hand side of our identity. Which is what we wanted to show. So, you know, the identity holds. Okay? Okay, so it's mainly just plugging and chugging. So when you go through your homework, I hope you have your kind of formula sheet in front of you. Let me take maybe a look at some of these and see how, see how they go. So express the solenoid difference. Let me get my notepad up too, so I can kind of do the work there. We'll make this one the video quiz question as well. I didn't really mention that, but this will be the video quiz question. I actually plan it to be a different one, but I keep forgetting. So if you ever need to, you can kind of email me and say, hey, Mr. Stroop, I missed the video quiz question. Can you tell me what it is? Sometimes I will, but sometimes I won't, because, you know, I have students that will ask me on that every video, and it becomes obvious they're not watching the videos. You know, sometimes I'll be kind of in a hurry and I won't have time to explain it. But you know, every once in a while it's okay. I get it. I've had to go through and watch my own videos, and it can be kind of annoying. I get it. Anyways, let me just make sure I put in my notes that this is the video quiz question. So we want to expand this thing. Let's see. It's sine of 8x cosine of 3x. We want to rewrite it as a sum or a difference. So you're going to have to go to that first set of formulas that I gave you. And let me get back to my notes then. Okay, so sine 8x cosine 3x. If you go back to that first set of formulas, so I basically gave you two sets of formulas today. If you go back to that first set, you look for sine, cosine, right? So that will be formula 3. And if you expand it, you'll end up with 1/2. And I'm just going to go ahead and distribute the 1/2, right? Usually the 1/2's on the outside. I'll distribute it. So it's 1/2 sine of alpha plus beta, so 11x, plus 1/2 sine of 8 minus 3x, which is 5x. Okay. And then hopefully that will be good enough. 1/2 sine of 11x plus 1/2 sine of 5x. Yay. Okay. That's the same thing except in reverse. So these are difference to so that takes the other formula, the second set I gave you. This one is sine minus sine, so that's formula 2 you're using. Okay, this was the video quiz question, people. So this was the video quiz. Anyways, let's look at this problem. So sine of 3x minus sine of 1x. And that's formula 2. So we'll have 2 sine of 3x minus x is 2x times cosine of 3x plus 1x, which is 4x. Oops, and they're both over 2, right? So it's 2x over 2, 4x over 2. So this will equal 2 sine of x cosine 2x. So let's put that in there. 2 sine of x cosine of 2x. Okay. That's the same thing, same kind of thing. So go this. That's formula 3. Same. Let's try this one. What the heck? It's got some fractions in it that kind of make it a little more difficult to work with. This is formula 2. So I have sine of pi over 12 minus sine of 5 pi over 12. Okay, so this will equal 2 sine of, and I'm going to write it out just to be careful. So pi over 12 minus 5 pi over 12 all over 2. That's what's weird about it. You get these complex fractions. And then cosine of pi over 12 plus 5 pi over 12 all over 2. So this will be 2 sine of negative 4 pi over 12. Divide by 2 is the same as multiplying by 1/2. You just multiply by reciprocal. And then we'll have cosine of 6 pi over 12 times the reciprocal of 2, which is 1/2 again. And then we'll have 2 sine of 2 goes into 4 2 times, and then 2 over 12 is the same as 1 over 6. So I have negative pi over 6. Cosine of 6 over 12 is the same as 1 over 2, and then that'd be pi over 4. Okay. And then sine is negative in the 4th quadrant, so this would be 2 times negative 1/2, and then cosine of pi over 4 is root 2 over 2. And so we'll have cancellation here, and it'd be negative root 2 over 2. That's our final answer. So let's try that. Negative square root of 2 over 2. Whoops. Negative square root. Oops, it's not giving me, so I have to go like square root of 2. So there's all kinds of shortcut keys for, so you don't have to actually hit the buttons. Sometimes it's quicker to memorize the shortcuts than to actually write it out. Oops, I missed that one. What did I do? Did I not multiply by 2? So let's make sure I get the formula right. Sine pi over 12, and this 2 sine of pi over 12 minus 5 pi over 12 is 4 pi over 12, which is basically pi over 3. and you end up with pi over 6. This is 6 pi over 12 is pi over 2 times 1/2 is pi over 4. Sine of negative pi over 6 is down here. That'll be negative 1/2. Oh, they don't even want you to go that far, maybe? They just want you to... That doesn't make any sense. Oh, because there's 2 parts. I am... Okay, so it's going to be 2 sine of negative pi over 6. Yeah. It can be annoying sometimes. Cosine of pi over 4. Whoops. And then, yeah, okay, that's what they wanted. Sorry about that. And then this is the negative root 2 over 2. /squirt. 2 over 2. There it is. This is just verifying the identity. Start with the numerator and simplify using the sum of the product formula. So we're going to use formula what on this guy? It looks like formula 2. Okay, so sine 7x minus sine x will end up being 2 sine 7x minus x is 6x over 2 is 3x. And then cosine of 7x plus x is 8x over 2x is 4x. And then all over, well, that's all they want. Okay, so let's try there. 2 sine of 3x cosine of 4x. Whoops. It's always something, isn't it? So what do I do? Sine minus sine, that's the second formula. So it'll be 2, 7 minus 1 is 6, divided by 2 is 3. And then the other one will be 7 plus 1 is 8, divided by 2 is 4. Sine minus sine, 2 sine. Maybe it's because I simplified it and I didn't write 3x plus 4x or something crazy. 3x plus 4x. It's 7x plus 1x. And then the other one is 7x minus 1x. I have the formula written wrong? What the heck did I do? Oh, I didn't divide it by 2. I gotta put that 2 on the bottom. Huh. Oh, that's a bummer. Alright. I'm going to put all this junk in parentheses and divide by 2. All this in parentheses, divide by 2. Oh, this is really turning into a nightmare. Oh, I got the signs wrong. Oops. The first one is minus, the second one is plus. Okay, well that's a sad state of affairs. Let's try the cosine minus cosine now that I know what I'm doing. So I'll have negative 2 sine of 7x, it's plus x over 2, and then sine of 7x minus x over 2. 2 sine of, whoops, 2 sine of, negative 2 sine of parentheses 7x plus x in parentheses over 2 in parentheses sine of 7x minus x in parentheses, and of course I used a capital, so that's going to not be a good thing. X minus x over 2. Always more work to do. In the numerator and denominator, substitute the expressions found in the previous answer, apply the appropriate identity to simplify the expression. Yeah, which I knew how much do they want me to simplify. All right, so anyways, the first one, 7x, I kind of have to go right back and redo that one because I don't really trust my answer here. So it'd be 6, I think this is right here, you know. And then, so it's, yeah. Is that the right answer they gave me? Yeah, they put the right answer there. So it's 6x over 2 is 3x, 8x over 2 is 4x. So that the thing I circled on my paper is right. Then this thing in the bottom will be negative 2 sine of 4x sine of 3x. So basically, I just have to put that chunk in here, I believe. 2 sine of 3x cosine of 4x. And then downstairs, I need to put 2 sine of 4x sine of 3x. And then supposedly I can check my answer here. Ooh, they're both wrong. Oh. Apply the appropriate identity. Substitute the expressions from apply an appropriate identity to simplify. Maybe they want us to totally simplify. So it's get rid of these things, right? And then I'll get rid of the 3x part. And then get rid of the 2. Don't worry, I talk to these people, these Pearson people every once in a while. I'll give them a piece of my mind for you, so don't worry. Using one, this, I believe that was a quotient identity. Ugh, that was Mike Marish. Okay, this is the same kind of spiel. I did one like this in the notes. Let's move on. I'm almost afraid to even try one more. Let's do one more, see if I can redeem myself, right? So that numerator, sine x minus sine y will become 2 sine of x minus y over 2 times cosine of x plus y over 2. This will be 2 sine of x minus y over 2. In parentheses, cosine of x plus y over 2. Okay, I think I'm getting the hang of it now. So sine plus sine is the first formula. So that will be 2 sine of x plus y over 2. And then cosine of x minus y over 2. 2 sine of x plus y over 2. My first job offer when I came out of college was working for one of these guys, these software systems that do homework. Kind of wish maybe I'd have done it, you know. It'd probably be interesting, but I don't know. Something tells me it's if they're having big errors, like if their homework is like this and it annoys enough students, I don't think they're going to be around for very long. So it's better not to get a job with somebody like that. Let's see if this one works. Check answer. Yay. I don't know. Anyways, probably simplify this thing. The 2's are going to cancel, and then you should have like tan, a tan from this one, tan of x plus y over 2, and then a tan from this one, so that would be tan of x minus y over 2, which is it looks like that's the right hand side there, right? So this one, sorry, is the tan of x minus y over 2, and then the other one, because it's cosine on top, is cosine of x plus y over 2. Or cotan of x plus y over 2, which is the right hand side of the identity above. So anyhow, I'm not sure how they want me to simplify this. Just divide out the common factor. The only common factor is 2. So we'll have sine of, I'm going to write this all out again, x minus y, whoops, yeah, divided by 2. Cosine of x plus y over 2, in parentheses, and I guess then we go in the denominator, sine of x, whoops, in our parentheses, x plus y over 2. In parentheses, and then cosine of x minus y over 2, and parentheses on that. Yay! And then, those are quotient identities. And then, oh, that's it. Well, this one's not so bad. It looks like they just give you the choices and not force you to type it in like some computer entry person. Okay, I think that'll do it for us. Good luck with that homework. Hopefully you've learned a little from my mistakes, and we'll see you next time. Okay.